I can have recording off of it as well here, and I can pause the recording. So real quick here, as far as schedule is concerned, just so we have 4.4 is up for today. We have the other trig functions, which we'll do. Then we have on Friday, bring your test corrections. We'll go over the test itself really, really quick. We're not going to take the whole time. And then we go from there. So remember, test corrections are, if you got it right, you're going to get an extra point for that problem that you missed. If you get it wrong, you still get 0. We good? But at least you know what the answer was. Right? That's kind of on the last test I had to do. There was a couple of people still got it wrong, so they didn't get full credit for the 1 point. Okay, boom. And then I kind of started putting the rest of it together here. So we have finished chapter 4, hopefully sometime next week. And then we have a few things that are happening here, just for you guys to sort of be in your mind here. We have the review for the test. We got to take the test itself. And then we have something called presentations. Presentations are, talk to you guys about it. But in a nutshell, it's something that you've been learning in the class itself, and you have one of two directions. Either dig deeper into the topic, like, oh, this is so cool, I never knew about, I don't know, something that you learned in the class. So like the history of the sine function. Like I totally want to know the history of the sine function, where it came from, what happened, what Ptolemy was thinking, all that good stuff. So you dig deeper into that. Or you correlate it to something you do in life itself. So the trig stuff up until this point, you say, oh wow, I see this in life. We good? So I'll give you guys some examples of stuff that was done last year. But it was curvature of a skateboard. It was musical notes, because musical notes go up and down, right? So then you have that correlation to trigonometry and how what makes a full sound. It was kind of cool. So anyways, I'll give you those. All right, we do also have a final exam that's coming up early part of February, and I'm not sure how I'm going to do that. So I'll see, because we need some time for that as well. Anyways, that's in the works there. We're good?
What's the difference between the written final and like an exam?
One chapter 4 and one
Written file would be all 4 chapters. Just a review of all the 4 chapters. Through the calculator coming your way. Okay, are we good there?
Oh wait, so it's all the things that we learned?
Yeah, Okay, so done with that. Let's jam to the lecture itself. Okay. Are we good? Ready?
Yes.
So 4.4, which we have is the other. Can't neglect tangent and cotangent. They feel lonely. The other trig functions are here. So before we get started, let's actually rewind the tape real quickly here and find out what they look like. So the tangent function, y is equal to tangent of x. Zoom, zoom. We have some critical points coming our way. So tangent function, we know, oh sorry, we already know that already. Is that right? The tangent function at pi over 2 has a vertical asymptote. And unlike the tangent, so cosine and sine function, some books, what they do is they start the tangent function negative pi over 2. Because it kind of gives you one complete set right there. So we have this little guy coming like this. Looks like a cubic function a little bit here. So we have something that looks like that. Boom. Okay. What are the main points we call critical values over here? Normally what we do is we say pi over 4 and 1 is a critical value. Negative pi over 4 and dun, da, da, da. Negative 1 is a critical value, as well as 0, 0. Okay, good so far. Some people just taking it up by osmosis, and some people taking notes. whatever you like. I figure taking notes is better though, unless you've memorized the tangent function. A few more things here, let's go with it. Some textbooks, what they do is they start off like right at 0, 0. I like this one. This one's a lot better. But we have to sort of notate the fact that this keeps on going and going, is that right? So let's add in just a little bit more. So this is pi over 2. That means that pi, that's my 0, 0 again. It comes across like this. And all yours, can you tell me what the asymptote is? And then can you tell me the next little dots that give me -1 and then give me 1? You get to fill that in. All right, anybody tell me this little dot right there?
3 pi over 4.
I'm gonna go with 3 pi over 4. We good? Just because you go back to pi over 4 over here, this is pi over 4, this would be 2 pi over 4. That means this has to be 3 pi over 4, which makes sense. This guy would be 4 pi over 4. Yay. That means this has to be
5 pi over 4.
I'll go with 5 pi over 4. Thank you. Boom. Okay, so there's that. Jamming. Next, we got 3 more to go real quickly here. Next one is secant. I'm gonna go with secant. Secant of x. All right, just like sine and cosine, this normally is graphed this way. Okay, just a little bit more. It sometimes goes backward this way. Usually front. Okay. Let's see. You guys talk to me here. When is cosine going to be 0? You guys give me places where cosine is 0. Actually, let me just come and label this real quickly here, like that, like that.
Pi over 4.
At pi over 4, does cosine become 0? I think we have this label for cosine, is that right? Cosine starts off at 0, 1, right? Starts off high, and it goes down, hits the x-axis at pi over 2, correcto?
Oh. So even though like you could shift the cosine around, it's still when you're talking about when cosine is 0. So, oh, okay. I guess my question is when you're talking about cosine in general and asking questions about the cosine curve and where the zeros are and stuff, should we just always assume that it's an original cosine
Yes.
curve? Okay.
Yeah. Because then I'll say, what is the 0 add 2 cosine 3x or something like that. So secant is the reciprocal of cosine, is that right? So whenever cosine is going to be like this, whenever cosine is 0, that means this is where this guy is going to be non-existent, right? It does not exist. So we have this happening there. And when a cosine comes up again, also this happens. So what we do, I guess I should save this here, saving it for later, but we graph secant based upon cosine. Once we set up cosine the way we want, we can graph secant here. All right, reciprocal of 1, that's the next one. What's the reciprocal of 1? When cosine is 1, take reciprocal of 1 and still be a 1, right? So there's my critical point. So cosine is 1 adds 0, 1. If we take the reciprocal of that guy, it's just going to be this guy here. Love it. And let's see, this is something kind of funny in mathematics here. If you have this right here, let's say 0.5, right? And then you have something looks like this. What's happened to the numbers themselves? I'm gonna, whoa, 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 whoa. As the numbers get smaller on the bottom, what happens to the number? It's the reciprocal of that number. Gets bigger. Are we good? Yeah, so in this case, when cosine gets smaller and smaller and smaller this way, our secant function gets bigger and bigger and bigger in this way. So it goes like that, extends out. Oh, something in the textbook. All right. Cosine is -1 at pi, so we're going to do this, and then we pretty much just graph this little graph that goes like this. This should be the high point right there. And then we finish it off going down, and we stop right there back at 1. So there's this secant curve. What we should notice, I guess, is this little piece right here. I'm going to draw the cosine inside it. So cosine would go like this. Bless you. All right, here's a cosine curve. Are we good? So notice I could actually draw the secant function based upon my cosine curve. So anytime the cosine curves hit 0, I know that's where the asymptotes are. Anytime the cosine hits 1 or -1, those I'm going to actually keep as my values there.
Why does the one on the furthest right go left instead of right?
Talk to me. This one right here.
Yeah. I can't see the pen, but I think
Sorry,
so.
right over here.
No, the other one. Just because the arrow goes to the left.
Talk to me about this one right here, this little arrow right here.
Yeah, is it?
Like it's going the opposite way.
Yeah, it's just weird for me to see the points going from right to left instead of left to right.
Gotcha. Okay. But in algebra class, didn't we have something that looks like this?
Yeah.
Y is equal to 1 over x, right? And so we had it's something like that in algebra 2.
Yeah, the
reciprocal
arrows
function.
are just on both sides. And
Oh,
so it's
gotcha. Okay.
just weird for me to see the singular dot,
Uh-huh.
and then it looks like it's moving from right to left instead of left to right.
Gotcha. Okay. Yeah. So let me handle that here. So this is just from 0 to 2 pi, right? Can we make it go on? Absolutely. This thing goes on,
Okay.
right? So if you want to, you can extend it out, and then we can keep on going forever. This guy can extend out, keep on going forever. So yeah, it does keep on going. Just giving you guys a graph of 0 to 2 pi. Okay, so cosine curve, there it is. Cosine curve is what we do with dashed lines. And then what we do is we connect the zeros with asymptotes. We connect the ones with dots and -1 with dots. Are we good? I think we're ready. Can you graph for me cosecant and base that upon sine, base that upon the sine curve? All right, and if you need to put dots of the sine curve inside here, that's perfectly fine. Dots of the sine curve kind of go like this. So that's why we spend so much time with sine and cosine. Okay, boom. And I'm going to go with this one. So it looks like at 0, 0, I'm going to have myself an asymptote. looks like at pi, I'm going to have myself an asymptote. And 2 pi. So there's 3 of them in there. It hits a positive 1 at pi over 2. That's perfect. So I'm going to have that little dot. That means it goes like this. And then at 3 pi over 2 hits a negative 1. So then I know it's below the x-axis. So therefore I have this piece right here. And yes, secant and cosine, secant and cosecant. Very similar. They're just offset of each other, just like sine and cosine. Okay.
So how do you know when to do like the 2 instead of like the half circle thing instead of just like on the other one, like 2 of them are just like these little curved things, not like half circles?
Sure. It depends where your asymptotes are. So if you just hit the 0, so for cosine, it hits 1 at 0, 1, right? So it kind of just stops there. And I'm just giving you guys from 0 to 2 pi. That's all we're doing here, right? Just going to give you one full cycle of it. Okay, and cotangent. Y is equal to cotangent x. Now we'll get started. Cotangent and it's usually given just like that. So 2 pi, pi over 2, 3 pi over 2. All right, so go back to your tangent graph real quickly here on your sheet of paper that you drew. And give me any zeros for tangent. Where are my zeros for tangent? 0, perfect. So I'm going to put, anytime I have a 0 for tangent, I'm going to put in asymptotes for my no, let me go back real quickly here. Let me go back to tangent here. We never finished it off, huh? If we wanted to finish off tangent, we could. It would just look like this. It does come up to 0 right here at 2 pi. There's my other little piece right here. We're good. So based upon this graph, can you guys graph the cotangent graph? So I have one more asymptote at 2 pi. I'm going to include that in there real quick here, my little graph. Boom, there. That's what I have so far. So based upon this graph, can you graph for me the cotangent graph? All yours, go. And as you guys are doing that, so as far as graphing is concerned, what we normally do is we have a very good sense of what cosine and sine look like. We have a very good sense of what tangent looks like. That's the 3. For secant, cosecant, cotangent, we normally, first of all, we don't graph them hardly ever in real life. There's only a few times where we're like, oh yeah, that fits a cosecant curve. But if we do, we base it upon sine and cosine and tangent. So we go back to those 3. Okay, so let's see what I got here.
Wait, where's the asymptote, like the farthest right asymptote? What point is that at?
Negative pi divided by 2.
Oh, my phone's right. So
This one right here? Oh yeah, that's right. So this has to be pi. This would be 3 pi over 2. 6 by 4, this would be 7, and then that little dot at -1, if we want to, that'd be 7 pi over 4, would be the -1 dot. All right, boom, boom, boom. I'm gonna go with it here. So based upon tangent, at pi over 2 is my 0, correct? Because that's my asymptote for tangent. Then I have another 0 at 3 pi over 2. So let's do this one first here. So also at pi over 4, which I did not mention over here, that's a critical point. That's going to hit me at 1, right? Because the reciprocal of 1 is 1. Let's go back to the other graph here. So at 3 pi over 4, I hit my -1. So I'm going to go over here. At 3 pi over 4, I'm going to hit -1. So that's what my little graph looks like there. So I have it coming down, boom, 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 and back down like this. Make it a curve. And then it starts repeating itself, because at 5 pi over 4, which we mentioned already in the previous graph, it hits 1. 7 pi over 4 hits -1. And 3 pi over 2 is the reciprocal or the asymptote for tangent. So therefore, it's going to be a 0 for cotangent. Boom. Okay. Let's see, about 25 minutes. I think we can do it here.
What's the dot between pi and pi over 2?
Let's see, pi and 3 pi. This is 5 pi over 4.
No.
Oh, this one right here. Yep, this would be 3 pi over 4. Thank you, Hayden. 3 pi over 4 for that one. Okay, we got our dots and our graphs. So let's jam. I'm going to concentrate on tangent because that's the one we normally use the most in our graphing stuff. So tell me when you're ready, or tell me if you need more time. Cool. All right, can you graph for me? Y is equal to 4 tangent of x. And specifically what I want a graph of -pi to pi. So as you get your graph paper going, think about how you're going to so that means this guy goes out to pi. This is pi over 2. What I really want for tangent, I really want a pi over 4 for tangent, because that gets me those those 1 and -1 markers here. So going the other way here, this is -pi over 2, -pi over 4, -3 pi over 4. Okay, at least I got that set up. And depending which way you want to graph it. You guys talk to me. What did the 4 just do for tangent? Not shifting. Not shifting up.
Oh,
It's the amplitude. In fact, we don't call it amplitude anymore because it doesn't go up and down, doesn't oscillate anymore, right? So it's not really called amplitude. We just call it a vertical stretch, right? We stretched it out. So at pi over 4, instead of hitting 1, now it's going to hit. It's going to hit 4. So all we got to do here is just to get our. Let's see. Let's put in our asymptotes in here. I think it's still at pi over 2, right? Didn't move there. And we know tangent is an odd function, so it's going to do the exact same thing on the other side as well, right? So we're going to go, the zeros are still going to do that. And I think we need to scale this here. So at pi over 4, instead of hitting 1, now it's going to hit 4, so we're up here now. And instead of hitting -1, now we're going to hit -4 down here. I think we're ready. And depending how you want to graph it, normally Or sometimes what we do is we start on the positive side because we at least see that graph and then we move on from there. So I know it hits 0 at 0, 0. I know it hits 0 at pi. I can go back to make sure. Okay, so I have this little stretch right here. It goes like this, and it's stretching that way up. Therefore, I know from the bottom, it's going to come over here after the pi over 2. It's going to come up, and it's going to get to pi there. All right, can you finish it off the rest of the way? And so I'm going to go just a little faster because of time here. So at negative pi over 4, we should be hitting negative 4. So it should be down here somewhere. So it should be a curve. Curves this way and goes back down. And at negative pi, it's 0 still. At negative 3 pi over 4, it's up to 4 again. And so we have this little piece again. Are we good? Raise your hand if you took some time with your homework to actually take a look at 4.4 prior to coming to class today. Like, you know what, I'm going to see what we're going to study in trigonometry today. I see. Maybe a good idea. Just to at least open up the textbook and just say, you know what, let me just sort of see what's going to happen here. I would say reading ahead, or at least seeing what's going on. That's the way I survived college. Because it's so funny, our brains sort of, let me put this in here and then I'll let you guys. Okay, same stuff. I'm going to change it up to 2 tangent 2x. Our brains work in 3 stages. First is just getting the vocabulary of something, just getting the, what are you going to talk about, the new vocabulary. And that seems to be a place where our brain works extra hard to get to. Because if you don't know a word, you don't even know what the person's talking about. Second is schema building. Like, okay, how does this relate to this? And how is this going to this? Second part. And third part is finally actually understanding it so that it just sort of sinks in and usually goes into long-term memory. And so one of the best things you guys can do is just to read ahead, just a section the night before, flip open the textbook, and just get a cursory understanding. In college, what I used to do is I used to actually just start the homework already. Just get some kind of understanding of the homework, see if I'm getting it right or wrong, or do the example problems, redo them before class. And then by the time I got to class, at least I had structure in place already. Okay, are we good? So I'm going to put it onto the side here. Vertical, stretch by 2. Are we good? There's your vertical stretch by 2. Oh, that's no fun. So that little 2x now, what is happening here?
Is it a shift to the right?
Shift to the right means it was like x plus pi over 2 or something like that. Yeah, that was the phase shift. This thing is the shortening of the period, is that right? It just goes like this. It's the compression horizontally or expansion. And so in this case, let's go with it here. So first things first is period. Let's see, for sine and cosine, the period was 2 pi, is that right? For tangent and cotangent, the period is just pi originally. And then what we do is we divide it by this little b value. Oh. Should not have the, come on. Erase that real quickly here. Okay. Okay, pi over 2 is now what we have. So instead of doing, we'll go back real quickly here and then we'll put it all together here. Originally, notice for tangent, if you start off at 0, it goes high, has our asymptote, starts off very low, and gets back to 0. We have pi as our period. In order for it to start recycling itself again, we have a period of pi. With that little 2 in there, now everything is going to go twice as fast. And so if we do this, we go out to pi. This is pi over 2, pi over 4, 3 pi over 4. Are we good there with the start of it? Jump to the other side. Now we're going to go negative pi. This is negative pi over 2, negative pi over 4. This is negative 3 pi over 4. Let's see what happens here. So those are the only two, right? We've got a vertical stretch of 2. We have a period that now is 2 pi. So for tangent, off to the side here, here's what I sort of think about tangent. Tangent does this. It goes like that, breaks, and comes back over here by the time it gets to pi. That's what we should sort of have in our mind, our little schema right there for tangent. Now we're going to do it twice as fast. We're good? So that means the 0 is still here because it hasn't changed. And so now we're going to build up from here. That means this guy is the pi over 2 now. So it hits another 0 at 2 pi, or pi over 2. So hold on, doesn't that mean that it also hits the other 0 at pi? Our vertical asymptote originally was at pi over 2, right? And if we divide, and if we scrunch it down by half, now our vertical asymptote is at pi over 4. Are we good? So that means the other vertical asymptote has to be over here. Okay. And our critical point, since everything got scrunched down by 2, so that means actually at pi over 8, ooh, new one here, pi over 8, it hits how much? It hits 2. Boom, there it is. Let's see, if this is pi over 8, that's 2 pi over 8, that's 3 pi over 8. So this is 3 pi over 8 now. And it's going to hit -2. So I'm going to put a little dot right there. Oh man, because we scrunched it down, now I have to actually label all the other pieces too. We good? So let's start labeling here. So this is 3 pi over 8. This is 4 pi over 8. This has to be 5 pi over 8. That's 6 pi over 8. That makes sense. This is 7 pi over 8. Yes. And that's 8 pi over 8. Yeah, which is just pi. So that makes sense. So that means at 5 pi over 8, it jumps to a +2 again. 7 pi over 8 is down at the -2 marker. Okay, are we good there? So can you guys graph the right side of it? And then can you guys go ahead and finish off the left side the same way? Kind of think about where those other pieces are. Okay, let me start it here. I'm going to go just a little faster just because of time constraints here. So I have this guy, which we just started, and then we have this connecting of the dots that comes in like this. And then we have the next one, which ends at 0. So going backwards, this would be -pi over 8, negative 2 pi over 8, negative 3 pi over 8, negative 4 pi over 8, negative 5 pi over 8, negative 6 pi over 8, negative 7 pi over 8. Good there. Asymptotes. Pi over 4, 3 pi over 4. And if we go backwards, we can actually kind of see the pattern that's going to happen here. That means it has to hit negative 2 at negative pi over 8. Comes back up. It hits positive 2, 0, negative 2, right in this little piece right here between these two asymptotes. And that means it starts back up again high and hits a positive 2 right here, and voila, hits the 0 at negative pi. Are we good? Okay. All right. You guys tell me if I need to slow down. We good? Otherwise, let's jam with one more for tangent, and then I'm just going to show you the other ones here. I got to show you cotangent and then the one either cosecant or secant, one of them here. All right. Let's put things together for tangent of, oh man. Oh, we'll graph one cycle. Okay, graph one cycle for me on this one. Let's do this one together. So graphing one cycle of this guy. So now we have the phase shift in here. We have a lot of stuff in here. Okay, so first things first, let's talk about this right here. So we have, first of all, a vertical stretch of 1/2, right? Which is really not a stretch, is really more a compression, right? It goes like this now, boom. We have a vertical shift, but let's talk about this right here. Notice the thing that's multiplying x is actually 1/2, right? So period becomes pi over 1/2. Are we okay with that one? It's this little b value right here. You can label this as the a value still here. You can do c and d if we like. So period is pi divided by b, which becomes pi over 1/2, which just becomes 2 pi. Okay, we have a phase shift on our hands, PS for phase shift. And the formula for it is, guys, talk to me. Did we have that right there as last time as a phase shift formula? Yeah, okay. So it's negative pi over 8 divided by 1/2. So multiplying by 2 here, multiplied by 2 here, that crosses that out. And I have a negative pi over 4, the phase shift. And I have a vertical shift. That's going to be 3 units down. Oof, okay. Okay, let's see if we can put this all together here. We might not be able to put it all together at once. So let's at least do this. We got to graph one complete cycle, first of all, right? So I'm thinking for my little phase shift right here. Notice I'm going to start off at negative pi over 4. And if I add pi to it, if I add 2 pi to it, let's see, you guys talk to me here. What is this plus this? Let's see, common denominator 4, that would make 8, right? So are we okay with the 7 pi over 4? So my graph is going to be from negative pi over 4 to 7 pi over 4. That's my little graph piece there.
Sorry, what did it say? It was negative pi over 4 plus.
8 pi over 4, which is the same thing as 2 pi. Okay. So let's start building this. I think let's start building this in stages here. So let's handle these two pieces first, and then we'll handle the other ones here. So vertical shift is stretches 1/2, so it's compressed down by 1/2. And the period is 2 pi. So originally what we have is we're going to go all the way up to 2 pi originally. We know we have phase shifts of 4, denominator of 4, so I'm going to put that in already here. So let's go, this would be pi, this would be pi over 2, this would be pi over 4. Are we good? I'm getting my little x, we call them tick marks, but lined up so that I know exactly where I'm shifting things. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi, 6 pi, 7 pi over 4. And 4, 2 pi over 3, 3 pi over 2. And eventually I'm going to wind up over here. I think we'll just finish up with tangent today here. So let's go with it here. So I know tangent is going to begin at 0, 0. So not really heavy on the dots there because it's not our final graph, right? We want to be able to shift it afterwards here. And so I know that's going to happen. I know everything is shifted. Everything is twice as slow now, right? Everything is shifting this way here. So by the time it hits 0 again, my original asymptote is right here. We're good at pi. So that means at pi over 2, that's when it hits 1/2. So that's a little dot right there. So let's see if this makes sense. Originally, it goes like this. And at 3 pi over 2, it's going to hit negative 1/2. Bless you. Okay, original. This is my tangent with a vertical stretch of 1/2 and a period of 2 pi. Are we good there? The important dots are 0, 0, pi over 2. This is 1/2 right here. 3 pi over 2, negative 1/2, and it hits the 0 again at 2 pi. Okay, so now let's take care of the phase shift and the vertical shift at the same time. Phase shift, it's going to go just back pi over 4. At this point, we're just going to go down 3 units. Ooh, you know what? I don't like the way I made my scale because that's 1/2. That means 3 is going to be all the way down there. Sorry, guys. Can I change my scale a little bit here? I should have had it. I should have had it closer here. This is 1, 2, 3. I'm going to call this 1, 2, 3 right here. Sorry. I'm going to go like that here. That's going to be my 1, right? So my 1/2 should be about right there. All right, so it goes like this. And it's going to come down like this with a dot right there. Let me erase the other stuff too here. Erase this dot and this dot here. So my Y scale, 1, 2, 3, 1, 2, 3. I should have done my Y scale because of my vertical shifting. Okay, I think we're ready. So it goes back pi over 4, and that little dot goes down 3 units. Are we good there? this little dot at 1/2 or pi over 2 1/2, it's going to go back pi over 4, and it's going to go down 1, 2, 3. Are we good? Or asymptote. Remember this asymptote at pi? That has to be shifted over.
Wait, so both of them are done? Like pi over 4 and negative pi over 4 are both in the same place?
No, this one's right at -3. This one's at -2.5.
Oh,
My vertical asymptote is at 3 pi over 4. This little 3 pi over 2 -1/2 now becomes 5 pi over 4 -3.5. Are we good? So it's actually down here. So 5 pi over 4 -3.5. And the 0, pi over 2 0 becomes 3 pi over 4, and then my pen is funny. There's what I got. Are we good? Kind of messy. Sorry about the messy part here. Okay, so I'm going to go this one right here. 2, 2.5 pi, and it's going to go up like this. This guy's going to come from the very bottom, comes up, and it hits the 3 marker there, and that's one complete cycle of 1/2 tangent x over 2 plus pi over 8 minus 3. Okay, come back Friday, we'll do our test review thingy, and we will go into cotangent, secant, cosecant. Just real quickly here on those.
so we're still in 4.4.
Still 4.4, haven't finished yet.